Now my dear students, we can see the question number 35, that is what is the correct electronic configuration of the central atom in K4FeCN06 based on crystal field theory. My dear students, what is the crystal field theory and what is the concept of crystal field theory? Concept and theory. We can now discuss this theory. According to crystal field theory, my dear students, when ligands come to close with d orbitals, and these are the d orbitals, and those d orbitals are degenerate d orbitals, means in which energy of the d orbitals are same. So those d orbitals in which energy is same are called degenerate orbitals. 1, 2, 3, 4, 5. So my dear student, this is called degenerate orbital, and when ligand is close to these d orbitals, electrons which are present in d orbitals are repelled with this ligand, negative charge of this ligand. So my dear students, the energy of this d orbital is increases and it is split into two parts. Number one, those orbitals which are pointed towards this ligand have higher energy level. So my dear students, here two orbitals in which energy is higher, that is dx square, y square and dz square. Now my dear students, in which three orbitals which are not pointed towards this ligand have lower energy, and so these orbitals are called T2g orbitals. So my dear students, this is called splitting, and this splitting is called, my dear students, it is called CFSE, crystal field stabilization energy, or this splitting is also called crystal field splitting. My dear students, here two orbitals are present, and those complexes are octahedral complexes. So we can write here CFSE or del O. O represent for octahedral complexes. Now my dear students, this is the basic concept of crystal field theory, CFT theory. Now here we can see in this question, which is asked in 2019 NEET exam, in K4FeCN06, when this K4FeCN06 is broken down, okay, and it is broken in water, so it gives us FeCN6 4 minus ion. Here my dear students, this iron Fe, atomic number of Fe is 26, that's why 3d6 4s2 electrons are present in this iron. Now when in this complex, oxidation state of iron is 2, 4 plus x minus 6 is equal to 0, so then x is equal to 2. You can get the oxidation state of iron is 2, means 2 electrons are removed from this s orbital, so you can get the 3d6 4s0. It means 6 electrons are present in iron. For example, if we take the iron element, and this is the d orbital of this iron, so here 6 electrons are present. So this is the d orbital of iron. But when my dear students, when ligand is come close to iron metal and d orbital of this iron, and this ligand is called cyanide ligands, because here you can see 6 cyanide ligands or ligands are attached with this iron metal. So my dear students, when these cyanide ions are close to this iron metal, then repulsion is occur between this electron of iron and this negative charge, because both are in negatively charged. So my dear students, here you can see energy is increases, this potential energy is increases, and it is splitting into two parts. Number one is 3 orbital have lower energy level, and these are dx square y square, and dz square have higher energy level, and dxy, dyz and dxz, these have lower energy level. So here my dear students, you can see here these electrons now fill in this way according to Hund's rule and Pauli exclusion principle. When electrons go to the lower energy level, then higher energy level. So my dear students, 6 electrons are present here, 1, 2, 3, 4, 5 and 6. Here we can see that 6 electrons are present T2g orbital. Why? Because my dear students, these cyanide ions are strong field ligand. Strong field ligand. When it come close to this iron metal, then splitting is maximum. Strong field ligands are those ligands in which close to metal ion to maximum splitting is occurs. So my dear students, here splitting between the difference between the energies is maximum between the Eg and T2g, or between these DD orbitals. This is also called D and this is also called D. So my dear students, 6 electrons are enter in the T2g orbital. So my dear students, here you can see here in this compound T2g get 6 electrons and here Eg gets 0 electrons. Why? Because as CN, cyanide minus ion, is a strong field ligand, are come close to each other. So energy is maximum. So next electron, fourth electron is not go to upper level. So my dear students, here what is the correct electronic configuration of the central atom in this based on CFT, and your answer is, my dear students, your answer is C. Why? Because due to this is your answer. So question number 35, you get answer C. Now my dear students, we can go to the question number 36. Question number 36 also come in NEET exam, NEET 2019. Aluminum chloride, my dear students, you can write here reaction. Reaction is that when this aluminum chloride reacts with water, aqueous solution, to form complex, A, in which hybridization state of aluminum is B. What are A and B respectively? My dear students, aluminum, when this aluminum chloride always reacts with water in presence of H plus ions, it comes close to AlOH2O whole 6, AlH2O whole 6 plus 3 ion. This complex is formed by the aluminum, means 6 water molecules are attached with this aluminum, and these H plus ions, this remaining the thrice HCl. So my dear students, this is the main product of complex of AlCl3. So my dear students, when this AlH2O whole 6 plus 3 ions you get here, and when this ion, my dear students, hybridization of this ion is, what is the hybridization of this ion? That is the, my dear students, it is the sp3d2. Why? Because here outermost d orbital are take part in this aluminum. So answer is A. Here 6 water molecules are attached with aluminum. So my dear students, one has 3p and 2 d orbitals are mixed together and form sp3d2. In this type of hybridization is present in this complex. So my dear students, you can see here aluminum chloride reacts with water in presence of H plus ions to form this complex, and hybridization is sp3d2. So my dear students, question number 36, answer is A. Now we can go to the question number 37. Here my dear students, the crystal field stabilization energy for this complex. Here we can see the concept and theory. My dear students, COCl6 4 minus ion is 18,000 and the CFSC for COCl 4 minus 2 will be. Here my dear students, you can calculate this number of paired and unpaired electrons, means you can draw the electronic configuration of CFE or CFSE. My dear students, cobalt. Here cobalt, sak t ba kar man phi ko. Ko means cobalt, means 27. You get the 27 atomic number for cobalt. That's why my dear students, you can get the outermost electronic configuration is 3d7 and 4s2. Here my dear students, cobalt is present in +2 oxidation state. Why? Because here when you can calculate the x minus 4 is equal to -2, then you can get the x is equal to +2. So in +2 oxidation state, my dear students, 2 electrons are removed from the s orbital. Then you can get the 3d7. Now we can see here chloride ion is a weak ligand. So my dear students, when d 5 orbitals are 1, 2, 3, 4 and 5 are splitting with each other by the coming of this chloride ions. But this chloride ion is a weak field ligand. So my dear students, separation of energy is minimum. Here 3 in COCl4. Here my dear students, here COCl4. So you can get the 2 and 3. COCl4 is the sp3 hybridization type. So when you put the 7 electrons, 1, 2, 3, 4, 5, 6 and 7. You can get the Eg, n is equal to 4 and in Eg orbitals. Because in sp3 it's a tetrahedral structure. So in tetrahedral structure, my dear students, Eg is not direct towards the ligand. Here T2G is present direct pint out towards the ligand. So energy of T2G is higher. So here T2G get the n is equal to 3. Now my dear students, here that's minus 4 into x, here plus 0.6 into y, and that equal to CFSE. Here you can get the 18,000, here you can get the 18,000 per centimeter. My dear students, here we have a relationship between the tetrahedral and octahedral stabilization energy. This is a tetrahedral for T and octahedral for O. So my dear students, if this is called octahedral and octahedral you can get the 18,000. So this relationship is tetrahedral complexes that will do 4 by 9 into CFSE of octahedral. So my dear students, this relationship you can also use. So 4 by 9 into here 18,000, because it is given by this octahedral complexes. Why you can see this is octahedral? Because here Cl6, here 6 ligand are present, that's why it is octahedral complexes. And octahedral complexes, my dear student, it is represented by del O. And here this is 4, that's why it is a delta T, tetrahedral. And this is the relationship between the octahedral and tetrahedral. What is the relationship, my dear students? Delta T is equal to 4 by 9 del O. So when you can see this relationship and you can calculate the CFSE for tetrahedral, that is 4 into 2000, and you can get the 8000 centimeter is a 8000 centimeter per centimeter. 8000 per centimeter is the CFST or CFT. So my dear students, here you can say that delta T is equal to 8000 per centimeter. So you can go the answer D. So you not need to calculate this CFC, because you can calculate the CFSC minus 4 into x plus 0.6 into y. When this relationship is not given, means you are not given this CFSC for octahedral, then you can calculate by this formula, and this concept is used. But if you have the CFSC of octahedral, then you can use the relationship, and this is the important formula. Delta T is equal to 4 by 9 into delta O. Now my dear students, question number 37, you get answer D, and this question is asked in NEET 2019. Now we can see here question number 38. Here my dear students, question number 38, the geometry and magnetic behavior of complex NiCu whole for R. My dear students, this is direct question. Here NiCu whole 4, this is a strong field agent. This is a strong field agent. So my dear students, here hybridization is sp3, and for sp3 hybridization you can get tetrahedral geometry. And all electrons are paired, because my students, dear my students, all electrons are paired. So NiCl4 gives, it's a diamagnetic nature. It's a diamagnetic in nature. So this is the answer. Answer is B, 38 answer is B. Now my dear students, we can go to the question number 39. Here we can see that correct increasing order for the wavelength of absorption in the visible region for the complexes of CO plus 3 ion is. Here my dear students, he asked the wavelength and you can see the CFT CFSE, crystal field stabilization energy. Crystal field stabilization energy is proportional to, what is the concept? Here concept, you can write here concept, because this question is also asked in NEET 2017. My dear students, concept is that CFSE, crystal field stabilization energy, is proportional to nature of ligands. If, my dear students, you can see here, strong ligands are present, then nature of strong ligand is strong ligand nature, then CFSE is maximum. So, my dear students, you can see here, strong ligand is present En, so CFSE, and this CFSE also known as energy. And we can say here energy of water is lower, then ammonia, and then En. You can see here energy of this water is minimum, and you can also get energy is E is equal to SC upon lambda. This is the formula. Means energy is inversely proportional to wavelength. My dear students, when energy is inversely proportional to wavelength, it means energy, higher energy get lower wavelength. So, when you can get the order of wavelength of En is lower, then ammonia and then water. So, my dear students, you can get the answer here water, because here order, increasing order for wavelength. He wants increasing order for wavelength of absorption. So, water has more wavelength than ammonia and ammonia has more wavelength than ethylene diamine. So, my dear students, your answer is D. Question number 39, answer is D. Now, my dear students, we can go to the question number 40. Here, pick out the correct statement with respect to MnCN whole 6 minus 3 ions. Here, my dear students, we can see the concept and theory. Here you can see the concept MnCN whole 6 minus 3 minus ions. Here cyanide ions, my dear students, have strong field ligands. So, my dear students, these ligands repel the electrons higher. So, outermost d orbital is pairing start, and my dear students, when pairing is done, then inner orbitals or inner d orbitals take part in the hybridization. And my dear students, when inner d orbitals take part in the hybridization, so here 6Cn is form the bond with manganese. So, here 6 empty orbitals are present in manganese, 2d, 1s and 3p. These 3, 4, 5, 6. These different energy level orbitals are mixed together, and my dear students, form the same energy level orbitals, and it is called D2sp3. So, my dear students, you can see here D2sp3 hybridization is present in MnCN whole 6 minus 3. Now, we can go to the question number 41. Here, my dear students, this question is asked in NEET 2016. Here we can see that John Taylor effect is not observed in high spin complexes. High spin complexes, it means high spin complexes, My dear, when high spin complexes are present, it means EG orbitals are incompletely filled or vacant. So, my dear students, in high spin complexes, or it is also called high spin complex, also called outer, this is also called outer orbital complexes. You can see here outer orbital complexes. So, my dear students, here it is outer orbital complexes. High spin complexes are also called outer orbital complex. And in this John-Taylor effect is that effect when ligand or ligands close to this T2G orbitals. These T2G orbitals, my dear students, are not present front of this ligands. And when you can see the EG orbitals, here EG orbitals are present in the front of ligands. So, repulsion is occur, and EG orbitals repulsion is minimum, and this distortion is called John-Taylor distortion or effect. So, it is not absorbed by when 8 electrons are present in D. So, it is not absorbed because in 8 electrons here EG and T2G present in front or in other sides not effect. So, it is not absorbed. So, answer is, my dear students, question number 41, answer is B, and this question is also asked in NEET 2016. In this question, my dear students, when you can put the 3 T2G orbitals and 2 EG orbitals and electrons are filled, 8 electrons are filled, then you can see here 1, 2, 3, 4, 5, 6, 7 and 8. My dear students, here you can see the in D8 8 electronic configuration here, these 2 unpaired electrons are present in EG, and EG is present in the front of ligand. So, John-Taylor effect is not affected because all the T2G orbitals are filled. So, you can give the answer B. Now, my dear students, we can go to the question number 42. Here, my dear students, question number 42, the hybridization involved in complexes NiCN whole for -2. But the concept, my dear students, concept and theory, you can easily calculate the hybridization. Calculate the hybridization. My dear students, in this question, you can easily calculate the hybridization. You can see NiCN whole for -2. 4 ligands are present. It means 4 orbitals are mixed together. It means it may be sp3 where 4 orbitals are mixed together, or it is a dsp2 when 4 orbitals are mixed together. Here, my dear students, you can see here cyanide minus ions is a strong field ligands. So, strong field ligands pairing the electrons, strong field ligands pairing the, and my dear students, when pairing the electrons is done, it means when pairing the electrons is done, it means d orbital is vacant. So, d orbital is vacant, and when inner d orbital is vacant, it is involved in the hybridization 1d, 1s and 2p. So, you can see the dsp2 hybridization present in this NiCN whole for -2. So, my dear students, answer, your answer is B. Question number 42, you get the answer B. Question number 42, you get the answer, that is, dsp2 is present in D. So, you can get the answer D, because dsp2 present in not B, it is present in D, and we can calculate this dsp2. Okay, and this is present in D. So, your answer is D. Now, my dear students, we can go to the question number 43. In question number 43, among the following complexes, the one which show 0 crystal field stabilization energy. Here you can concept and theory, you can see here concept and theory. My dear students, here iron is present. Okay. When we see the iron, iron is present because first of all we see the iron. Okay. In iron, +3 oxidation state is present, electronic configuration is 26, 3d6 and 4s2, and when iron is present in +3, then you can get the 3d5 and 4s0. This electronic configuration is present in Fe+3. Now my dear student, when you have a 5 d orbitals 1, 2, 3, 4 and 5, and here splitting is done. My dear students, splitting is done large or minimum. Here you can see here which type of ligands are present with iron. My dear students, you can see the water ligand is come with iron, and when water ligands are come with iron, it is a weak field ligands. So splitting is small. And my dear students, when splitting is small, so splitting is small. When splitting is small, my dear students, it means electrons are filled 1, 2, 3, 4 and 5. Here you can see here Eg orbitals and T2g orbitals. My dear students, why these Eg2 orbitals are present above and below? Because here your structure is Fe H2O whole 6 and here +3. Here 6 ligands are attached with this iron. Here in all the options you can get the 6 ligands are attached with this metal. So this is the octahedral splitting done. Now my dear students, when you can calculate the CFAC for octahedral, -4 into X and -0.6 plus -0.6 into Y. Here X is the Eg or T2g and Eg orbitals. So electron is a -4 multiplied by the here 3, and here this is the plus -6 is multiplied by the 2, because 2 electrons are present in Eg, and this is so X for T2g, number of electrons present in T2g, and here Y represents for number of electrons present in Eg. So my dear friends, you can put the number of electrons here 3 and here 2. So you can get the here -0.4. It is a -0.4, -0.4, and here my dear student, it's a +0.6. Here this is a +0.6. Here this is a +0.6. This is the formula. -0.4. Formula is -0.4 and +0.6. Now we can calculate the minus here 1.2, and here this is the plus 1.2. 0.6 multiplied by 2, that is equal to 1.2. 6 2s are 12, and 3 multiplied by 2 minus 1.2. So del O means CFAC energy minus and plus. So these are cancelled with each other. You can get the 0 CFAC percent in this complex. And question is that among the following complex, the one which has shows 0 CFAC. My dear students, you can calculate in all A, Mn. When Mn is calculated, first of all, you can write the atomic number of Mn, Sakti-ba-kar-man, 25. Electronic configuration is 3d5 and 4s2. Here you can see the 3 electrons are removed because Mn is present in Mn plus 3. So my dear students, electronic configuration is 3d4, 4s0, and you can fill these 4 electrons in this manner, 1, 2, 3, 4, and put the 3 electrons in X and 1 electron for Y, and calculate the CFS. In this way you can calculate the all options and get the answer. So my dear friends, you can go the answer B, 43, question number 43, answer is B, and this question is also asked in 2014. I thought you can easily understood. First of all, we can make this electronic configuration. Next, second step, we can fill the electrons in T2 and Eg. In third step, we can write the formula minus 0.4 into X plus 0.6 into Y. And fourth point, we can put the values of x and y, and fifth point, after calculation you can get the answer. So my dear students, this is the answer. Now we can go to the question number 44. A magnetic moment at 1.673 bm will be shown by one among of the following. Here my dear students, I give you some trick for solve this type of question. Here first of all, mu is equal to 1.73. It means unpaired electrons is 1, that equal to 1. So you can find out the unpaired electrons first of all. Here you can see if you see copper, for example copper atomic number is 29, 3d9 and 4s2, but one electron come in d orbital, so you can get the 3d10 and 4s1. So I can write here 3d10 and 4s1. My dear students, when this copper is come into plus 2 ions, then 2 electrons are removed, one from here s and one from d orbitals. So my dear students, you can get the 3d9 and 4s0. It means you have one unpaired electrons. My dear students, when you can get the one unpaired electrons, it means Bohr magneton is magnetic moment is 1.73. This is the trick. You can also calculate it by the formula. And what is the formula? Magnetic moment is equal to root n plus 2. Here when you can put the values of unpaired electron, that is 1 plus 2, then you can get the root 3, 2 plus 1 means 3. And my dear students, root 3 is the 1.73 Bohr magneton. This is the answer. So you can get the answer from the formula as well as my trick. And this type of questions are in NEET exams, because this question is in NEET 2013. Now my dear students, you can enjoy my tricks as well as formulas also. Now we can go to the question number 45. Crystal field splitting energy for high spin D4 octahedral complexes is, my dear students, octahedral complexes, high spin. High spin means here all are present in unpaired. Here 4 electrons, 1, 2, 3 and 4. All are present in T2G and EG orbitals. Okay, it is a high spin, my dear students. High spin means unpaired electrons are maximum. So unpaired electrons are present high spin. Now we can means strong field agents are present, are come close to metal ions. So it make the high spin complexes. Here del O, because he want the octahedral CFT. Del O, my dear students, that equal to, we give your formula earlier, minus 0.4 into x plus my dear students 0.6 into y. Here this is belong to T2G orbitals, number of electrons, and this belong to EG electron. Here my dear students, minus 0.4 multiply by the number of T2G electrons, that is 3, plus multiply by the 0.6 into 1. Here my dear students, you can solve this question. Here you can get the 1.2 minus and plus 0.6. So del O, you can get this minus 0.6 del O. This is the CFAC for octahedral complexes. So this is the answer. You can get the answer easily, and answer is B. So question number 45, you can get the answer B. Now we can solve the all questions which are asked in previous examination of NEET, and I give you, my dear students, tricks, theories and concept in each questions, so we can cover the all chapters through these questions in this crash course. I hope this crash course is very, very useful for my dear students. Thank you very much.